So the first part of the circuit was the transmitting circuit, which basically allowed for the audio input of different audio signals from a microphone and an aux cable. The aux cable was usually connected to a computer that was playing some sort of sound or a phone that was playing something from Spotify, and then take those audio signals and amplify them to make them a little louder, because as they went into the circuit, because of all the resistance, the signals were a little low, so op amps were used to amplify those signals. Then those signals needed to be mixed using another op amp, and then that final amplified signal needed to be transmitted via a laser at the end. So here's the actual circuit from a top view perspective. Now going part by part, initially here we see the part of the circuit that allows for audio input from a microphone, as we can see over here, and then a phone, as we can see over here. So the microphone takes a 9-volt input for its power source, whereas the aux cable only needed a phone, which powers itself. So from the audio inputs, we have what is known as a high-pass filter. We can see here there's a capacitor connected to a resistor, and down here again a capacitor connected to a resistor. And what that basically allows the circuit to do is establish a lower boundary value at which certain audio frequencies cannot pass anymore. And this baseline frequency is determined by the formula F equals 1 over 2 pi RC. So we aimed for about between 30 and 40 hertz as a frequency as a minimum, because those lower frequencies can usually cause a lot of noise. So after that frequency, you get a lot more clearer sound. So we did those right before the amplification, so that going into the amplification, we had a really clean signal. So next we have the non-inverting op amps. We have one on top here, one on top here, and one on bottom here. So basically the way the non-inverting op amp works is that the positive is grounded, and then you have your signal going into the negative input, and then that negative input is amplified by the ratio of RF to RI, which is why in both these situations you see RF, the top resistor, being a lot higher than the input resistor. So then those audio signals were amplified, which brings us to the next op amp. And in the next op amp, we have the signals from the microphone, which is on top, and the phone being added together, summed, which is why this is called a summing op amp, in this op amp here, which is once again another non-inverting op amp, where we have the feedback resistor on top and then the other resistor here to create a gain to make it louder. So here we have what is known as a bias T. So what a bias T allows us to do is when you have an AC and DC input, it allows you to create a DC offset to power the laser. So the components that you need for this are a capacitor, an inductor, a resistor, a voltage source, which is just the same 9-volt battery that we've been using, and then a laser. So basically, the laser was receiving the DC offset from this amplification, so it was actually powered and was able to transmit a signal. So the second part of this project and circuit was the receiver circuit, which had to take the signal from the transmitting circuit and turn that light signal from the laser into an audio signal and being able to play that on a speaker. So this was accomplished in 3 parts. Number 1, receive the laser light, which was done via a photodiode. Number 2, amplify the signal, which was done via more op amps. And 3, play it on a speaker. So here is the circuit diagram again. So as you can see all the way on the left, we have a photodiode, which is able to receive the laser light signal. After that, we have a resistor to make sure that the photodiode doesn't get overloaded with voltage. After that, we have another high-pass filter comprising of a capacitor and a resistor to make sure that there is low noise after the photodiode received the signal. After that, we have another non-inverting op amp, but instead the top was this time a potentiometer instead of a regular resistor, because that allowed for the control of the volume that was actually going to the speaker. So it still acted in the same way because the potentiometer was able to fluctuate between 1K and 10K ohm resistance, so it was able to act as a feedback resistor while the other one was just the initial resistor to create a gain. After that, the output from that op amp went to the speaker, which is all the way to the right, and the speaker was able to play the audio. So those are the 2 parts of the circuit, and now we can see what they actually look like. The actual circuit that we created from a top perspective. So we can start out with the transmitting circuit. So actually we'll start out with the batteries. So with the batteries, we have 2 9-volt batteries here. One of the positive ends is connected to the positive rail, and then the negative rail is connected into the ground rail. And the positive from the other is connected into the ground rail, while that negative is connected into the negative rail. So that basically allows us to have a ground as well as +9 and -9 voltage going into the circuit, which is what we needed because 4.5 was a little too low. So now going to the transmitting circuit, Up here we have the microphone with the high pass filter with that capacitor and that resistor beneath it. Then over here we have the aux input, which is now connected into my laptop, going through another op amp. So for the microphone, I use the op amp that's on the left side of this op amp over here to amplify it. And then for this one here, I just used a different op amp. So then those signals were amplified, and then they were brought via this green wire and via this orange wire to the summing op amp, which is over in the middle here. And that summing op amp, the output was taken to the middle of the circuit board here with this capacitor and inductor and resistor configuration over here to create the bias T, which is then connected to the laser, which is over here. Now we have the receiver circuit. So the receiver circuit, we have the photodiode, which is right there, connected into ground as well as to that resistor. And then we have the another filter at the top of the op amp to filter out a little more noise. And then we have the op amp itself connected to the potentiometer, which acts as the feedback resistor for this circuit. And then we had to adjust that a little bit to figure out like what kind of volume we could get from it. And now just to show how the laser works and how the circuit works. If we are to press play on our good friend Yodel Boy over here, oh, now press play, we can see that, hopefully, the laser's been kind of finicky, but yeah, see, the laser itself turns on most of the time, so we have that. And then if we were to shine it on the photodiode, like that, so the sound can't really be heard in this video itself, but when we did our demonstration in class, if you put your ear right up to the speaker, you can actually hear the audio. The problem with our circuit is we weren't able to get enough gain, and it may have been because of the op amps that we were using, or if we were using enough op amps, or if the current was high enough. But if you were to put your ear to that speaker, you'd actually be able to hear it. And just as proof as to the audio is being transmitted via the laser, I can put the speaker into where the laser is. Yeah, so if I were to put that where the positive input of the laser was supposed to go, you can clearly hear audio coming out of it. So audio is being transmitted from the laser, but it's just not being received and amplified enough by the receiver circuit. But overall, the circuit does work. We were able to transmit audio and we're able to receive it. So overall, this is how the circuit is able to work. Thank you so much for watching, and have a good time with this project.